Welcome back to the Mobile World Congress discussion zone here in Barcelona. And our next speaker is Rui Frazeo, who is Chief Technology Officer at Vasona Networks. And Rui will be presenting on building a bridge to 5G from the mobile edge. Rui, I shall leave you for your presentation.
Thank you very much. So good afternoon, everyone. I've done actually this presentation on Monday. I'm not sure if anyone saw it. So then I have the surprise effect of the introduction. This is actually my second time on stage in Barcelona. First time I've been on stage in Barcelona was 25 years ago, down there in that place for the Olympic Games in 1992, where I was fencing for my home country, Portugal. Now, back then I thought this is the biggest challenge of my life. Little I know I would join telecoms. I would be working for a mobile operator. I work for Vodafone. And I would have to face one big challenge after the other, starting to roll out 3G networks, and then LTE networks, then virtualizing the mobile core, and trying to launch VoLTE as the first commercial service in Europe. And all of those challenges kept coming and coming. So conclusion is, there's always more challenges in front of you, either being telecoms or in life, and you need to be prepared to address them with a different perspective. Now, at Vasona, we're looking at those challenges from that different perspective. We call it a perspective from the edge. We are a software edge compute company that has been working with the telecom operators to provide new solutions, innovative solutions, to deal with the lack of visibility that they have today on application performance, and improve that application performance to meet the customer expectations. We have a number of high-scale deployments across the world where we've been helping operators on their 3G and 4G networks to gain more visibility on what's happening in their networks. Our platform has the ability to track in real time usage down to the cell level. And what I mean cell is sector carrier level of the radio network of the mobile operators. And we're able to understand how many users are there, which type of applications are being served, and then we take a number of actions that improves the performance of those networks and extends the capacity that has been invested in those networks. One of the main focus that we had is around video. And this is because video has been growing massively, and it continues to grow. So that has been the focus for the last few years. And we've recently started also looking into other applications, time-sensitive applications, like the move towards IoT, and building the necessary platform to address those. So what is one of the biggest challenges besides computers not working? So besides computers freezing, one of the biggest challenges that operators have is the way they look at networks, the metrics they use, average coverage, average capacity, gives them a limited view when it comes to what is the customer experience, what are they facing from an application. It tends to be often a different perspective and a different experience. Customers care about how well does a video stream play on my phone? How many times does it stall? What is the quality? Or how much time does it take to load a browsing session? How fast does my social media feed refreshes? Those are the metrics that the customers look into. And the carriers have had the challenge of trying to match their perspective of the network to those metrics and the quality of experience of the users. Now, that also has an impact in terms of investments. There's a lot of investment coming to mobile networks. The question is how much that investment really impacts the customer experience. So average coverage or capacity or even tariff is no longer a differentiator. It's the customer experience, the next frontier of differentiation. Having an analogy with a car. So this is like driving in a car that is telling you a bunch of relevant information, like average speed and how is your car performing in average, but it doesn't really tell you how fast are you going to get to your destination? What is the best route to your destination? And how much traffic exists? So this is more or less where we are in this industry. And there's a promise coming with 5G that we're going to have a much better network, smarter, faster network. And that will enable also a number of additional use cases, and that would solve some of the challenges that we have today. However, before investing in 5G and making all those big investments, we should try to understand better what are those metrics that we should be improving and target those investments in that direction. We've been deploying our platform in the edge of the mobile operators network, and we've been working with an ETSI standardization working group called MEC, Multi-Access Edge Computing. Through that standardization, we've been working with a number of use cases where you can actually deploy software from different vendors and have that software cooperate at the edge of the network, benefiting from that visibility and from the perspective of being closer to the customer and the ability of handling better services from a latency perspective. So we believe that before moving forward and make all those investments, we should understand better, try to leverage the investments on a 3G and 4G networks using edge compute platforms, and make the necessary infrastructure change and prepare it for 5G. One of the examples that we've been working is in a use case called throughput guidance. This is a MEC use case, and throughput guidance is about sending information from the network which is relevant for the content providers. We've been working particularly with video streaming content providers, and this example you may recognize. As you move along in with your mobile phone or tablet, very often you have stalls, the video stops. That's not the experience that you want. That's a frustrating experience, and most of the people actually stop watching those videos. With throughput guidance, we have the ability, as you'll see on the left side, to signal to the content provider what is the best bit rate that they should be serving, meaning what is the best quality of video they should be serving that particular stream in that moment that copes with the network conditions. This means that the video will be able to adapt in real time to the conditions, and if there's a congestion coming up, which we can predict, then the video will lower the resolution, it will not stall, and the moment that there is no further congestion or you move to another radio access element which has more capacity, you immediately increase the quality of the video. And that brings up the quality of experience in metrics that matter to the customer. So reducing stalls and increasing the quality of the video.
Just to clarify, so you do this for carriers and OTTs? Could you repeat it for the microphone so we can...
Yeah, sure. The question is just to clarify, I understand this correctly, whether this works. I mean, you mentioned that you do this for carriers, but this also works for OTTs in the content space that ride on top of carriers, or how should I think about this?
Yeah, exactly. Actually, we are the project we are in is with an OTT content provider and the carrier. So the content is coming from an OTT provider. The technology works for both sides, so either operator-owned content and distribution platform, or for OTTs. The technology we're using is being standardized. We're part of that standardization. I mean, the way of signaling. It's an IETF standardization working group where we define within the stream where do we insert that information. So that's standardized and can be used by any platform. The specific solution where we're running this, we've been running this trial for a few months now in a big city in Latin America. And we've, for instance, last week alone, we've inserted more than 1 billion throughput guidance messages. So you can see the number of video sessions and the number of change of network conditions that we've been coping with. And by using this technology, we've been able to improve the video quality and reducing stalls by up to 30%, increasing the quality, overall quality of the video session, and even reducing the start time of video. And this has been So this has been managed also and been visible from the content provider side. So there's a let's call it a win-win situation in this case, in the sense that the mobile operator is able to provide a better user experience and avoid, at a certain level, congestion. Content provider is also sure of the quality they are delivering to their customers, and ultimately the customer themselves are happy with the quality that they are delivering. Now, this is an example of a particular case which is very sensitive for users nowadays in terms of experience in the mobile network, and we did not have to increase capacity on the 4G network or even wait for 5G to provide a better user experience. So that means that the investments done on the network can be leveraged further, and at the same time increasing the customer satisfaction. So looking forward, there's a number of other use cases that you can think of which are different from the traditional browsing or even video, where people are looking for specific quality when they're using these services. If you're paying during a mobile payment, you want that pay to happen immediately. You don't want that payment to last for 2 or 3 seconds. That gives you a bad experience. So that means that you need to understand from the network that there is an electronic payment transaction, not just bits and bytes. And there's a number of other use cases, like in IoT with low latency cases, where people are saying you need to wait for 5G to try them out. Reality is that adopting edge computing and MEC technology within your network, you can already start experimenting those services, hosting those applications at the edge of the network, figuring out what are the metrics that are valuable for the customer, and then when you move to 5G, you target those investments in those areas, you gain experience. And you've been building a platform which is built on a generic computing, software-based, and can be reused towards 5G. Bottom line, what we're saying is that today, with the current infrastructure that we have, you can actually enhance the experience by adopting a software approach towards the edge of the network, and you can build a platform for 5G and get a head start on 5G applications. That heads to the question and answers.
Marie, thank you very much for the presentation. Excellent presentation. Now, we've already had one question from a gentleman in the audience. Do we have a follow-up, or do we have any more questions from our audience? Good. Just one.
Yeah, I wouldn't mind understanding a little more the edge computing aspect, so how the application gets deployed and how I should think about that from an architecture perspective.
Okay. So in terms of when it comes to generically edge computing, what we're saying is there's a part of the network which traditionally does not run any intelligence. So there's an element of an infrastructure element that you need to build at the edge of the network. Now, the edge of the network is a broad concept. Some people think because mobile networks have been built with radio access networks, so the tower cells, and then the core on the other extreme. So when you talk edge, they go straight to the radio access part of the network. That's not necessarily the case. So there's a place within a location between the RAN and the core where you can actually start building that infrastructure. And that's a good point to start in the sense that you can maximize the number of applications that you can run on the same compute infrastructure. So most of the times this is the location called central office, where you aggregate your eNode B, so the radio access network. That's the place that we advocate as the best place to start. Now, as you continue developing and building this generic computing infrastructure, it can actually run in any part of the network. So if your routing and switching becomes engineering computing, so that same routing and switching platform can be used to run more intelligent applications, or even ultimately the physical radio location when it becomes generic computing. But you need to find the right trade-off between the cost of deploying compute infrastructure and the availability of compute power versus the application and what the application is bringing as a benefit to the infrastructure and the customer. That's the physical element. Then the application element is how do different applications cooperate with each other in that same location. And that's where also Etsy Mac is focusing.
Rui, thank you very much indeed.
Thank you.